Hi, we are ProxSeat, and this is our preliminary design review of the EliteSeat product. Today we will be going over the introduction to our project, our background, our problem statement, our concept of operation, the functional requirements, the conceptual block diagram, our performance specifications, our functional block diagram, the responsibilities and schedule, the assumptions, our broader impact, and then we will conclude with the project deliverables. And my name is Madison Collier, and I am the project manager.
My name is Christopher Smith, and I'm the hardware engineer.
My name is Riley Purdy, and I'm the software engineer.
And my name is David Bob, and I will be the systems engineer.
We would like to thank our faculty advisor, Dr. Michael Okwan, as well as our project sponsors, TD Industries. The live entertainment industry is facing three main challenges. There is currently the human factor, which can be associated with both the consumer and the employer. Guests at these venues can be faced with confrontation over people in the wrong seats, which can lead to a negative experience. The cost of employing people to work these events is also increasing as time goes on, which in turn leads to increased ticket prices, which consumers never like. These venues are slowly, if at all, shifting towards automating their practices, leaving room to increase overall efficiency. Lastly, this is relevant in times like pandemics like COVID-19, where we are attempting to implement social distancing, but also bring back live events in order to keep people in that industry employed.
The entertainment industry is one of the last big industries to significantly rely on the human factor. ProxSeat's mission statement is to design a product that makes venue seating more efficient, less confusing, and makes the core memories of life as stress-free as possible. The EliteSeat aims to accomplish exactly that. Consumers will have a simpler experience, and stadiums will be able to continue working towards automating their operations.
For our concept of operation, the EliteSeat will include a smart locking device that will unlock when the corresponding NFC tag is detected. In the case of a lost tag or mishap, a master key will allow for the seat to become unlocked until the event ends, or it'll allow it to enter into a debugging mode for potential troubleshooting.
There are four subsystems that make up EliteSeat. The first is an NFC tag reader. It is battery powered, connected directly to the PCB, and mounted on the seat in order to give the user easy access. This component will also determine if the seat should be locked or unlocked. The second subsystem is the actual locking device. Like the NFC tag reader, it will also be battery powered and directly connected to the PCB. It will be mounted in the hollow part of the seat where the locking bolt can go through the metal frame. The third subsystem is an NFC tag. Each one will be programmed for a specific seat. Unlike the NFC tag reader and the locking mechanism, this requires no battery. It uses passive technology by utilizing electromagnetic induction to create current in the tag. The last subsystem is an NFC tag programmer, which will be purchased off the shelf. This will be used to program individual NFC tags and requires 120 volts AC. Next, we have the conceptual block diagram. It shows a basic overview of how EliteSeat will be implemented. In the upper right-hand corner is an NFC reader. It is, like I said before, it is directly connected to the PCB, which is the green box on the lower part of the seat. The PCB will also house the Raspberry Pi microchip. The battery pack, which is the pink box on the left, will be fed into the PCB. The PCB is going to regulate voltage to the NFC reader and also to the locking mechanism, which houses the solenoid and the locking bolt. David will go more in depth about the specifics of the system in the functional block diagram.
The conceptual block diagram for the software is split into two portions, the Central Assignment Unit, or the CAU, and the EliteSeat Locking Unit. The CAU will import the preset NFC IDs and launch the user interface above the event start. After selecting the correct seat, the program will assign a corresponding NFC ID to the user's tag. The locking unit on the seat will constantly be looking for the user's tag or for the master key. If the user's seat is closed for more than 3 minutes after unlocking, the seat lock will begin looking for the user's ID again. If the master key is detected at any time during the seat being locked, the seat will remain unlocked for the rest of the event and will enter into the debugging mode for troubleshooting.
Now, covering the performance specifications, we will start off with a solenoid that we'll be using to physically lock and unlock the seating portion of our system. We have calculated that for the size of the solenoid we are going to be using, we will need a 12-volt DC battery pack with a minimum of 4 AA batteries in order to extend the operating life of a single battery set to a full season or several months worth of entertainment shows. For the NFC reader, the model we have chosen requires 3 volts of DC. Now, this power comes directly from the custom PCB we'll be building with its integrated voltage step-down conversions needed to go from our 12-volt battery pack down to 3 volts. Now, a pretty cool little feature of the 2040 chip that we'll be utilizing is that it has a built-in sleep mode when not in active use. And when in this mode, we estimate that approximately less than 0.05% of power will be used in a single 24-hour period.
For the central assignment unit, we will be using a pre-built Python library for NFC programming. This will allow us to use a USB NFC reading device to assign a NFC ID to the user's tag so it'll correspond to their ticket information. We will also be creating a graphical user interface, or GUI, to allow for a user to easily assign NFC tags to the correct ID. The software on the EliteSeat will also be using Python libraries to read the user's NFC tag and compare it with a preloaded NFC ID to lock and unlock the seat or to enter it into the master key mode.
This is our functional block diagram detailing the flow of the operation from start to finish. Starting up here at the top with the NFC writing subsystem, the NFC writing software will be established on an independent computer, ideally at an entrance kiosk. From here, the writing device will encode the NFC tag with a unique identifier that will be used to unlock a specific seat for a specific individual. That individual will then take that tag to their seat where an NFC reader will be integrated directly into it in an easily accessible area. A multicolor LED will be placed next to this reader that will then be used to visually indicate the status of the system, such as locked or unlocked. The NFC reader will then send its data to the heart of the EliteSeat system, which is the custom PCB we'll be designing. The main component of this PCB will be the Raspberry Pi 2040 microcontroller. This microcontroller will be used to control all the data operations that we'll be needing for this device to work. Also included on this PCB will be all of the accompanying circuitry and components that will have to be used, such as a voltage buck regulator and a mechanical relay. The main power bank will also be tied to this PCB. Once the necessary computations have been performed, an unlock or lock signal will be sent to the solenoid. The moving of the solenoid bolt will trigger a physical micro switch, which will then alert the Raspberry Pi to the current status of the seat and allow the operation to cycle properly.
Our network logic diagram covers the overview of the timeline of the project. Here you can see the breakdown of major tasks and the duration it will take to complete that task. As you can see from the legend in the top right corner, the numbers are representative of the weeks spent on the project, and the red denotes our critical path. We've accounted for some slack and attempted to keep the project on track as efficiently as possible. This is the start of our work breakdown structure, also referred to as a WBS. The WBS is broken into 5 main components: research, hardware, software, build, and completion. We will break these down further in the following slides.
The main components of the research portion will involve scope, components, product specs, and a high-level programming overview. These will then filter down further into deeper levels of research needed. Examples of this will include things such as looking into which SMD components will be needed, PCB design requirements, power consumption of all the integrated pieces, etc. Now, the main research elements of the programming side will be what exactly are design parameters in terms of the capabilities and limitations of the code that we will be building.
Hardware will be split into 3 sections: the locking device, which will lock and unlock the seat, the PCB, which will be designed specifically for our needs, and the physical stadium seat in order to install EliteSeat and test the system.
While I described both of the software elements I created while speaking on the conceptual flowchart, after implementing the programs, we will be testing both programs for any potential bugs and integrating them both into the hardware units.
For the physical build portion of the full device, we will be combining the software portion in the microcontroller into the hardware side consisting of the locking mechanism. Now, we have allotted several steps into this to ensure an orderly process. These steps will build off each other in a logical and sequential order until a final product will be ready to present to TD Industries.
The final phase of the project will be mainly administrative as we proceed with all of the final documentation and securing the approval from our sponsors and advisors. This is our responsibility assignment matrix. Each row here corresponds to a portion of the WBS. We have denoted the primary and then the secondary leads on each portion of the project. For the research phase, we all have a part in the project initialization, and then we each have a part in researching the different portions of this project.
This is showing how I am the primary member that is responsible for all things hardware, including the locking device, power source, PCB design, and system testing.
For the software portion of the work breakdown structure, you can see that while I am the primary lead on software development, fully integrating the software into the system will be a group effort between me, David, and Chris.
Finally, this breaks down the actual build and completion of the project. It shows how David is primarily responsible for integration and the final product design, while Maddie is responsible for all things completion, including the documentation, demo, and sponsor approval.
Our Gantt chart here shows the project start week, and then I can input the first week I want to display. It then follows a similar chronological order structure like the WBS and gives an overall task description. The progress can then be edited and shown as the gray bars on the right-hand side. On this portion of the Gantt chart, it displays the build section, and the bars are purple because there has been no progress made on this task so far. If I were to go and edit the display week number, I would be able to go back and see that it looks the exact same under the design phase, as that is part of the project that we are not at yet.
While creating the EliteSeat, we'll be working under the assumptions that the seats will be resting in an upright position until the user folds it down. The seats will be hollow enough for us to attach our unit onto it, and the seats cannot be removed or tampered with easily. During creation, we'll also take into account our limitations, such as a limited battery lifespan for each unit, a potential locking device that will take into account the number of units that will need to be created as well as the small size, and a simple enough troubleshooting method to take into account the lack of trained personnel that would be on site. Some of the obstacles we have set to face while creating the EliteSeat also includes finding an efficient and practical way to power the devices and to keep them powered. We will also need to create a unit that is water and weather resistant and will make the NFC reader easily accessible by the user.
Taking a look at the bigger picture, EliteSeat can offer the entertainment industry a unique product that allows their fans peace of mind, knowing that their seat will not be taken by anyone else before they arrive. EliteSeat has the ability to maintain jobs through a pandemic as it can allow proper social distancing. EliteSeat can help the entertainment industry continue to grow by using technology to modernize the user's experience. For example, this technology can simplify the user experience by streamlining things such as merchandise, food or beverages, and future ticket sales.
At the end of this project, we here at ProxSeat will present our deliverables consisting of NFC assigning and writing devices along with a physical locking chassis system to our sponsor, TD Industries. Now, by blending existing technologies into a new and customizable approach, we hope to facilitate a positive customer experience at entertainment venues across the world. This product, however, need not be necessarily limited to venue seating in the future. Looking forward, this package will also be applicable to other scenarios such as where more than a few people will need access to individual seats, equipment, supplies, etc. on a changing basis, such as shift work. The technology behind EliteSeat could become a force multiplier in productivity and accountability.
From all of us here at ProxSeat, thank you so much for taking the time to listen to our PDR today. Thanks and gig 'em.